All right, so we've got this problem here. A particle moves along the x-axis according to this equation. So this equation right here is actually a position equation for this object as it's moving. It tells us where it is at every second. If we plug in any time, it'll tell us exactly where it is. So for part A, all we need to do is plug into our equation. So I'm going to go ahead and do that right here on the calculator. We've got 1.97 plus 3.04 times, it's not going. We've got 1.97. We've got 1.97 plus 3.04 times 3.3 seconds minus 1 times 3.3 squared. So we get 1.112 meters as our answer. For this next one, and let's see if that's right. Looks like we got that one right. Next up is find its velocity at 3.3 seconds. So this is the equation for velocity, or for position. We need to find our equation for velocity. And since velocity is equal to the derivative of position with respect to time, we're gonna have to do our power rule. So we're gonna look at each of these terms individually. This first term has t to the power 0. So when we take the derivative of that, we get 0. The next term is t to the power 1. So we multiply by that in the front and change the exponent down to a lower number. So we're going to multiply this by 1 in the front, and then this t to the 1 becomes t to the 0. So we get 1 times 3.04 t to the 0. Plus, well, this next term is actually minus, so I guess I'll just put that in as a negative. Minus, and now what we need to do again is we're taking this exponent, which is a 2. We're going to multiply by 2. 2 times 1 times t to the 1. And so when we rewrite this whole thing, we get 3.04, and no t here because that's t to the 0, minus 2t. And this would be our equation for velocity as a function of time. And so we go ahead and plug into this equation right there. We will get 3.04 minus 2 times 3.3. And as you see here, this becomes negative 3.56. So I think that should be our velocity right here. And the negative just means it's moving to the left. There we go. We got that one right. And the last thing is now we're going to use this velocity equation to figure out the acceleration. We didn't exactly discuss this in detail, but that acceleration is actually equal to the derivative of velocity with respect to time, because it's the change in the velocity. So we're going to take the derivative one more time. And so we're going to do the same thing we did before. Here we've got t to the 1, and here we have t to the 0. In front of the 3.04, there's a t to the 0 there that we don't need to look at, but it's there. And so we take the derivative of a constant, you just get 0, because a constant doesn't change as the time changes. And this is what this derivative means, is that the time is changing. Then we're going to do minus 2 times the exponent times 1 times t to the 0. So this just becomes that the acceleration is equal to negative 2 meters per second per second. So that's our answer for this last part. There we go. Hope that helps. Let me know if you have any other questions.